Hi students, problem number 2. Two slits are 1 millimeter apart and the screen is placed 1 meter away. When blue-green light of wavelength 500 nanometer is used, then the fringe separation has to be found. So this experiment is from the topic Young's double slit experiment. So in Young's double slit experiment, do you remember that two slits, that is two openings A and B, are separated by distance small d, and the screen is always placed at a greater distance d. So this distance is taken as d. Okay. So this is the midpoint of the screen O. So we are going to use two different symbols for D. One is small d, the other one is capital D. So this is the screen on which the interference fringes are being formed. So first of all, what is given here? Small d is the distance between the two slits which are acting like coherent sources. So two slits are 1 mm apart. So here small d is equal to 1 millimeter. So that is equal to 10 power minus 3 meter. And the screen is placed 1 meter away. So capital D is equal to 1 meter. Now the blue-green light of wavelength of the light is given. Lambda is equal to 500 nanometer. So 500 into 10 power minus 9 meter. Also it can be written as 5 into 10 to the power of minus 7 meter. The fringe separation is beta. Beta is equal to how much we have to determine. Very simple. This is the simplest possible problem I can say in this Young's double slit experiment. Okay. So beta is now equal to lambda into capital D divided by small d. So lambda is substituted, it's direct substitution, that's all. So this is 5 into 10 power minus 7 into d is 1 meter divided by small d. Small d is 1 millimeter. So this is 5 into 10 power minus 3. So here the powers get cancelled. No, 10 powers get cancelled. The remaining is 10 power minus 4. So this is equal to 0.5 into 10 power minus 3 meter. Therefore, beta is now equal to 0.5 millimeter is the answer. Direct substitution only. You can check here. Option A, B, they are not correct. Option C, that is the correct answer. 0.5 millimeter. So option C is the right answer. Okay. I hope you must have understood this well. Fine.